everyone, it's Michelle
and Steph,
and welcome back to the Inspired Podcast, a podcast hosted by UVic's Inspire program, which focuses on STEM for social impact. This season, we're stepping beyond the syllabus and engaging in conversations with some of your favorite professors.
Joining us today, we have Dr. Mark Laidlaw, who many of us know from taking his first-year Physics 110 and Physics 111 classes. Well, welcome, Dr. Laidlaw. Thank you so much for coming on our podcast. I think we're ready to get started with our first question.
Okay. Awesome.
What was university like for you, and what would you have done differently?
Oh my goodness. I came in to university doing something which I would 100% not recommend, which is I didn't have a plan. I honestly came in, thought, what am I going to do? Well, I like math, I like physics. Maybe there's going to be a job at the end of it. Who knows? And just kind of path of least resistance into math and physics degree. So as far as what university was like for me, it was probably, at least at the start, really insufferable for the people who were sitting near me. You laugh, but I'm sure that there's been at least one or two in a lot of the first and second year courses that you're in, somebody who's really, really, really sure of how smart they are and wants to ask questions that do more to communicate that than to actually ask a question. Like, I didn't realize I was doing it at the time, but looking back, oh my gosh. Yeah. So one of the things that I did in the first year, which was really valuable, even though I didn't, in retrospect, really like it, I took a sociology course. Like, the thing that was super valuable about it was it really opened my eyes to the fact that there are people who, it's not about having different opinions, but like, think different things are interesting than I do. Like, it was really eye-opening, and I'd heartily recommend to anybody in science or engineering that they need to take a course, at least a couple of courses from. I'm going to gesticulate towards that side of campus, so over towards Clarahue or where sociology lives.
Totally agree with you on taking a course that's completely out of your realm, if that makes sense. I mean, yeah. I took a philosophy class, and I'm in engineering. I'm biomedical engineering, mm-hmm. and it was actually really interesting. I learned a lot that I didn't expect that I would learn in that class, and it was actually like a pretty enjoyable class.
Oh, for sure. So something else I really enjoyed doing was I'll call it taking courses vicariously. So my wife and I, we knew each other through university, and she was taking courses like Greek and Roman studies or biology, and I was motivated to spend some time with her, and she was motivated to do some studying, and so there was some synergy there, and I got to learn a lot about Greek and Roman studies, the different gods doing different things. At one point, I knew the difference between mitosis and meiosis.
Oh.
They're both biology things. The other thing I did, I went into the co-op program. And so I ended up doing a total of 5 work terms with different places.
Like, what kind of different co-ops did you take, and how did you benefit from each one of them, would you say?
I did 2 co-op terms with the Ministry of Environment. The next work term I did was for a startup. It was in Port Coquitlam. And what they were doing was they were making brain scanners. So I see you two looking across at each other. So the story behind this, it's so physicsy, it's super fun. So in your brain, what happens is, like, when the nerves go off in your brain, they send little bits of electricity. I think it's ions go from one part of the nerve to the other. But we've got moving charge, and that makes a current. And the fact that there's a current, it does 2 things. First of all, the current makes magnetic field. Second thing the current does is, since the places where the charge are moves from one place to another place. And so if you cover a person's head with really sensitive electrodes and then surround that with really sensitive magnetic stuff, they were superconducting quantum interference devices, which could measure really small magnetic fields. Then you can, from the electric and magnetic fields, work out where the activity in the brain was happening. And the whole idea of this, like, they were imagining that it was going to be particularly useful for, say, somebody who had epilepsy, because, as it was explained to me, not an expert, but some things like epileptic seizures are essentially triggered by repetitive signaling of nerves in a specific part of the brain. And if somebody was going to, say, operate to treat that epilepsy, they'd need to know really well where the nerves were. And the idea was that if we could figure out where the activity in the brain was, we could help the surgeons. This was one of the closest things I got to a real world application, but it turned out that the salespeople had told whoever was going to be buying these machines that it would be possible for them to have the patients, like, on their back in the machine. However, because the quantum interference stuff had to be covered with liquid helium, it was like, if you did that, there would be these currents which made the readings unreliable. And so during the time I was there, they were really freaking out about, is there a way that we can make these things work for somebody lying down? And I don't know if they solved it, because the co-op term was only 4 months long, but I learned a lot about programming there. I spent a work term at Triumph, and what I was doing was basically a literature search for how neutrons interact with heavy metals, and trying to parameterize this in a particular model. They never let me once even in the same building as the actual experiment, because they knew that I was a theorist, and I break stuff in the lab, so that worked out for everybody. The co-op program, in my experience, is just wonderful, and I super recommend it to anybody.
Awesome. I mean, we obviously know that co-ops are pretty important, because in engineering you have to take 4.
Mm-hmm.
And we're on co-op right now. That's why we're doing a podcast and why we're at school today.
Wait, you're not doing it just for the joy of talking to me? Because, I mean, I would think that would be the main draw.
That's, of course, what Stephanie was saying.
That's what I meant. Okay. My next question is, have you ever failed a class? What about in grad school? Did you ever struggle in your courses?
Oh, okay. So did I fail a class? No, but oh my goodness, I'll take you back to the fall of my 3rd year, to a midterm in physics 321A, classical mechanics 1. And it's the same sort of material that we do in physics 110. It's just more. And so came in there, trot, feeling all confident. I sit down, I open up the first question, and the best way to describe it is that there was this 2-hour window which corresponded to exactly when the exam was, when I could not do math. So, I limped my way through the exam, and I thought, okay, well, I know I messed up some of the math part, but I'm sure I put some stuff that was right-ish, so I'll get partial credit. And A couple days later, the instructor walks in and says, okay, well, here's the deal. The class average out of 30 was 17. Top mark was 26. Bottom mark was 4. He starts handing them out. And so I hear that and I think, okay, well, 15 to 20. I feel bad about that. But no, it was the 4. And so I did one of the classic things, which is I got the paper, I looked at it, and just got up and left. And was wandering around disconsolately. And then I decided, revenge is best served cold, so I started studying. And final exam rolled around, and I know I answered every one of those questions correctly because I was going to show him. The guy is on faculty at UBC Okanagan, so we run into each other at conferences sometime. He does not know the sort of the scar that left, but it's there. And probably the closest I came to failing was in grad school. So I was taking a year-long quantum field theory course, and we had a midterm exam just around Christmas, and it was 5-day take-home exam, and I was spinning my wheels with it. So then now it's day before Christmas. I'm walking down from my office to get a coffee, and I make the mistake of going past my supervisor's office. And he's sitting there typing away on his computer, and I don't know, he must have seen me go by. So, hey, Mark, that's how his voice sounds in my head. Hey, come in here. So I do. He's looking down, type. So, I saw your midterm. Type. Here's the deal. Do better next term or find a different supervisor. That's all. You can go. So I went from putting 6 to 10 hours a week into that class to putting 30 to 40 hours a week into that class. And it went a lot better. And that was the time I finally learned that you get more out of a class when you do work.
Yeah, fair enough.
I have a follow-up
please.
to that. I know that you spend at least a little bit of time on the UVic Reddit. One of the questions that I had asked that you had actually answered was about who your favorite professor was. You mentioned the professor that you had, or maybe a couple. Do you remember who it was?
Well, I can remember 3 that I would have specifically mentioned. So one of them was Harry Dosso. He was chair of the physics department back in the 70s. So by the time I started here as an undergrad in the 90s, he was like on the verge of retiring. And the thing that stood out to me about him was how much this man clearly loved his job. Like he'd come walking into that second year geophysics class. He's wearing his lab coat, just this big smile on his face, and he starts talking about physics. Big smile on his face. You could ask him anything, and he'd chat at you. You could, like, before the colloquia, there'd be coffee and cookies, and you could go and talk to him about anything to do with physics. And he was just the happiest person to be talking about physics that I've ever seen. And like, if I was going to say something that I really admired about him, like, he was the one who, when I looked at him, I said, that's a way that I hope to be. Like, I guess I assumed he was 90 or something. He probably wasn't. But as I was 20 and I couldn't tell, but when I just, like, I wanted to be that happy in what I was doing, and seeing how happy he was probably the thing that first made me think, oh, maybe grad school is a way to go. Now, another person that I would have mentioned was Fred Cooperstock. there was something that he did that sort of impacts me and that I use in my teaching even now. And what he'd do was he'd have the final exams. He'd book a room, and the final exams would be starting at 9:00. And he'd hand out the exams and say, "Okay, start writing. I'm here till 5 or 5:30. Hand it in when you're done." And it was an exam which was reasonable as long as you didn't get hand cramps in the 3 hours. It was an attempt to give people a chance to put their best foot forward. As much as I can, that particular practice stuck with me. Okay, the last person I'm going to give a plug for is my colleague Michel Lefebvre. So he's currently one of the senior members of our particle physics group, and he's wonderful. He's a great colleague. I very much value his input about a lot of things. But as a student, the thing that stood out for me about him was one day he was teaching Physics 413. It was a quantum mechanics course, and he came in, and he was so mad. We asked, "What are you mad about?" Well, he'd just seen the new James Bond movie. "Why are you mad about that?" "Because of how bad the physics is." Now, so the setup for this movie is that James Bond is on some, I'm going to say, Russian ice station thing, and he's trying to blow something up, steal something. I don't know. It's a James Bond movie. He's doing one of those things, and the only way off of it is on an airplane, and somehow in the people shooting at each other, hijinks ensue stuff. The airplane starts taxiing and goes off the edge of this cliff, and it's falling down. So what does James Bond do? He gets on his motorcycle and drives the motorcycle off the cliff, jumps off, and dives into the open door of the airplane, like you do. What was so offensive about that? Well, the fact that the person just falling under the influence of gravity was able to overtake something that was the propeller was exerting a force pulling it downward, so it should be accelerating faster. How did he catch up? This was there was a good 20 minutes of outraged physics content that came from that, and it's one of my fondest memories of undergraduate teaching. It was amazing.
I remember Physics 110, there's the acceleration story. For reference, the one I'm talking about is the one I think is in Las Vegas, about the train.
Oh, that one. My wife and I are on vacation in Las Vegas. I forget which hotel it was, but we were in one hotel, and there was this little monorail that goes out around the neighboring hotel to the next one, which is owned by the same chain. And so we get on, it's standing room only, and I reach up, hold on to the little handrail, and I hear this voice saying, please hold on, the train is about to accelerate. I'm like, oh, good use of the word acceleration. Thank you. And then we speed up, and now we're about to turn to avoid the next building. And I hear, please hold on, the train is about to turn. And then finally, as we're coming into where we're going to stop, please hold on, the train is about to decelerate. And at this point, the physicist in me is like, no. So I wanted to go and find the manager and tell them that I could have saved them 60% or more in their voiceover, because all of those are actually acceleration. Speeding up, that's acceleration. Turning, that's acceleration. Slowing down, that's also acceleration. And I was really determined to find it. And then my wife kindly pointed out that we had a dinner reservation, and maybe they'd want to hear about it another time. And I guess now they're hearing about it on the podcast. So you're welcome.
Now they know this, they're gonna change it. They're gonna take that into consideration. They're gonna be like, you know what? We're gonna change it.
I hope that they do. And then I can point to that and say, look at that. I did some good in the world of physics.
Lasya, do you have any other questions? I had questions written down, but we're kind of getting pretty long.
No, I think that's all that I think a good thing to highlight is like the fact that like it's very interesting that you did a lot of co-ops, because normally, obviously, like in engineering, it's very much you're supposed to take work terms.
Yeah.
You have to.
You have no choice. But it's very interesting to hear like that you'd really recommend it to everyone, because I feel like that's very important. I feel like for anyone.
I mean, you can find out something about yourself, what you're good at, what environment you like working in an environment where even if it's terrible, it's just 4 months. I think it's really valuable that UVic has engineers and science people doing co-op, because as you find out what your discipline is like, you can then find out, you can kind of decide, is that the direction I want to go? Or maybe you do something that you didn't know was interesting, and it makes you change your direction a little bit. So like that's what I think the beauty of co-op is.
Awesome. You've been such a great guest, to be honest.
We are incredibly grateful for you to be here for sure.
My pleasure.